Hi everyone, welcome back to Art of the Part. In this video we're going to continue on with our fidget spinner case study, and in the last video we left off on the fidget spinner blank, which is going to be our master file or our parent file to be inserted into our design files or our children or our child files. So we're going to make this fidget spinner blank, and then we're going to insert it into a SolidWorks design file or part file, and we're going to now draw the 3-spoke spinner or maybe even the 5-spoke spinner, whatever design that you're working on, out of that parent file. So all these files will be our child files, and this will be our parent file. So I'm going to keep the fidget spinner blank open in the background on purpose. That's our parent file, because when I go into the design file or our child files, I want to be able to pull from whatever parts that I have currently open in the background in SolidWorks. So let's go ahead and click on File, New, and you might see this screen right here. You can go ahead and click on that part and hit OK. I'm going to actually use my Nunik part template because I have all of my dimensions and background set up. So inside of this new part file, I want you to make sure that we have the parent file or that fidget spinner blank open in the background. And there's two ways that we can check that. We can go up here into the top toolbar and we click on Window. And underneath Window, we can see which files that we have currently open, and I can toggle and click between them. Likewise, I can hold down the Control key, and this is the hotkey version of that. And while holding down the Control key, I'll click on Tab, and I can actually toggle through and tab through whatever files that I've currently open. So I'm going to make sure that I have that open in the background and come back here to the new part that we created. So up here in the top toolbar, we're going to go ahead and select Insert. So Insert. And then under Insert, we're going to select Part. So Insert Part. And then, like I was saying, as long as you have that parent file open in the background, it's going to recognize that there are files that you can actually insert that are currently open. So inside this Insert Part properties here, I'm going to click on Fidget Spinner Blank. And this is going to operate a lot like SolidWorks assemblies, in such that if I randomly drop this part in 3D space, it's going to place that origin or the part in reference off of the origin of the child file or whatever file that we're referencing here. So I think that's bad practice, and I think it's always good to lean on as a default option to go ahead and just hit the green check mark, because you can see that the part will actually snap to the origin of the file that we're referencing. So there's some other options down here you can look at. So for instance, you can choose to either bring in certain pieces of geometry or exclude certain pieces of geometry or features here. So if I had planes turned on, we can see how the planes will actually import from the parent file. One option that I do like to always include whenever I'm doing insert parts is to use this locate part. It's just going to include a locate part feature. So if I ever have to, change the part's origin in X or Y or Z or rotate it, it's already there and I don't have to go ahead and try to mess around with it. So make sure that locate part is on. We'll select the part here and then we'll click the green check mark so it snaps and locks to the origin. And when I hit the green check mark, it's just saying that there's a different template of units set, and I'm just going to hit yes. They're truly the same. I use the same template on the first part and this part here. And here's that locate part function or that feature that we turned on. So like I said, I can choose to rotate in like X, Y, or Z, or move in different dimensions here. But I'm going to leave that the same because I want the origin of my parent to match the origin of my child. And I'm going to hit the green check mark. Okay, so you're going to see here that a new feature was logged here in the feature tree, which is going to be that insert part. And this is going to operate like any other feature inside of SolidWorks. So if I hit the expand here next to the fidget spinner blank, you can see all the different pieces of geometry that were included when the part got inserted. So for instance, these planes, they're going to start to get in my way. And honestly, those planes are exactly the same as all these planes that are in the child file. So what I'm going to do is I'm actually going to go ahead and right-click on that fidget spinner blank. And you can do this with any number of features that you want to either include or exclude, but you can right-click on that fidget spinner blank and you can choose Edit Feature, just like how you would edit a feature inside of a different piece of geometry. So you click on Edit Feature, and I'm actually going to turn off that planes now. So I'll click off the planes, and I just have my solid bodies and then my sketches here, and I'll hit the green check mark. And it's going to try to locate the part again. We'll just hit the green check mark. But now you'll notice that the planes are gone. However, they're still existent in the parent file that we're referencing. So you have a lot of control in what you can either bring in or exclude. So that said, let's go ahead and get started here with our drawing of the fidget spinner. So I'm going to collapse this down and I'm going to start a sketch here on this top face. So I'm going to click on that top face and then I'm going to get this quick toolbar here to hit sketch. So it's going to reorientate me and look head down on the part. And one thing to consider is that the fidget spinner blank that we drew had an outer diameter of 3 inches. Now take a look at this outer diameter for the pocket of the fidget spinner itself. It's 2.875. So we're actually going to be a little bit shy of the raw material outer diameter. So keep that in mind, especially when you're drawing this. Don't accidentally make your geometry tangent to that outer edge. It might be a good habit to do that, but in this instance, we are going to be cutting that away and you're not going to get the geometry that we're seeing here. And another thing I want to talk about while we're looking at this blueprint here is notice that this is cut equally into 3 different segments. So right now I'm seeing this separated by a portion of the pie, or 360 degrees divided by 3 is going to be 120 degrees. So we're looking at this portion right here, and if we pattern that around in 3 places, because we see that this is 3 places, 3 places, 3 places, so it's a circular pattern of 3, we're going to get the full 360 degrees from that 120 degree segment. So let's keep that in mind in how we approach drawing this fidget spinner, okay? So something to keep in mind here too, 2.875 is that outer diameter, and then we're going to have a 1.125 as the inner diameter or the extent of the pocket as well. So I'm going to start off by drawing up some construction geometry as well as my lines or my angles of where I'm going to either like mirror or pattern around. Okay, so we started that sketch. I'm going to go ahead and use the circle tool, and then I'm going to link myself to the origin, and I'm going to drag a circle out somewhere not outside of the circle of the outer diameter of the raw material, but somewhere just shy of it. And then we'll do the same thing. We'll click another circle here, and then we'll drop it right there. So one thing to consider as well is if we keep this as is and we continue to draw our geometry and we go to extrude, these solid lines are going to be considered geometry that you want to include with the cut extrude. So we want to reference these as construction lines. So I'm going to hit escape a couple times, and then I'm going to click on this circle or this diameter here. And in the properties on the left-hand side, I'm going to choose it and toggle it to be for construction. And we'll do the same thing for that inner circle there as well. So I'll do for construction for both of these, so that when I do complete my geometry and I go to cut extrude, it's not going to try to include those with it. Okay. I'm also going to smart dimension them. I'll just make this one, say, 2.875, and then we'll do the same thing here, and we'll make this 1.125. So those dimensions came from the drawing, and you can see them right there and there. Okay. Next thing I'm going to do is I'm going to look at that 120 degree split. So I'm going to draw a construction line. So inside of the sketch tab, underneath line, I'll hit the drop down and I'll get the center line here. And I'll lock myself or link myself to the origin. I'll click on the origin and I'll drag a line up. Make sure that you're seeing that vertical relationship, and we can actually link it to the 12 o'clock position or the top of the quadrant of the circle that we drew for 2.875. So I'll link that there. And then I don't want to continue to draw lines here. I'm going to hit the escape key. But again, I mentioned in the last video, if you wanted to, you could go ahead and retoggle another construction line. But if you just use that previous feature, you can hit the enter key on your keyboard and it'll bring it back up. And I'll go ahead and place another line here. Now, one thing to consider, we could go to that full 120 degree value. However, we should probably start looking at this in such a way that I could probably mirror it over from this side to that side. So that 120 degree value, we can actually divide it by 2 and get to 60 and then mirror it over that 60 degree angle. So what I'm going to do is I'm actually going to drop a line here, make sure that it's coincident with this outer diameter, and then I'll hit escape, and then we'll smart dimension, and we'll smart dimension this angle here from this line to that line. So I'll click there, and I'll click there, and instead of it being 120 degrees, which I would have to draw both sides of this, I'm actually going to make it 60, or I can type in 120 divided by 2. And then I can draw this portion of the fidget spinner and then mirror it over this line and get my full 120 degree wedge to rotate in my circular pattern. Okay, so I have all the reference geometry that I need to go ahead and move forward with the hard geometry of the outer extensor, the profile of this fidget spinner. So the way that I drew this, this outer diameter here is going to be in line with this through hole of the locating pin. If you are looking at making like a 5-spoke or a 7-spoke, you might not be able to take advantage of the same techniques. However, here I'm going to use this to my advantage here. So I'm going to minimize my drawing. I'm going to open up my circle tool. And if you were drawing this without the locating pin, we'd have to draw another bolt circle or reference circle here at 2.5 and then dimension it accordingly. However, I'm going to just wake up this through hole. And you can see here, if I wake this up, I'm going to move this 60 degrees so it's out of the way. If I hover over this circle here, I get to see the center mark of that through hole. So I'll click on the center mark of that through hole, and I'm going to drag a circle out until I snap to the top of that quadrant or the tip of that line. So I have a circle that is now linked to the center of this through hole, and it's tangent with that 2.875 diameter. All right, so I have to start processing this in such a way where when I'm mirroring it, I don't include more geometry than I need. So what I need to do here is actually trim this piece of geometry so that it doesn't get mirrored over with the 60 degree angle. So I'm going to go into Sketch, Trim Entities, and inside Trim Entities, make sure that you have Power Trim activated. And the way to use Power Trim, again, you click with the left mouse button, hold it down, and then you drag it, and then you release the left mouse button, and that's going to cut anything that it crosses away. So here I'm going to cut across, and then I'm going to now, and this is another feature, if I click on a line and then I drag it back, I'm not going to actually remove that line, I'm just going to shorten it. So if I click on this line and I click on maybe the bottom half of it, I'm going to drag it back, and I'm actually going to pull it back to there. So I'll hit escape, and now I can take advantage of that endpoint to now make a tangent arc and then have it run tangent or coincident into this intersection. So I'm going to grab the tangent arc. So inside of Sketch, we'll go to Arcs, Tangent Arc. Hit the drop-down menu. It might default to 3-point arc, but I'm going to get tangent arc. I'm going to make a tangent with this endpoint, and then my second click is going to be at this intersection here. And then I'll hit escape. So right now, if I click on this line, I see a tangent relationship between this arc and this arc. And if I drag this, it's actually going to show or display that tangency. However, I don't want this arc to go behind this diameter of 1.125. So I'm going to have to establish an additional relationship. So I'm going to hold down the Control key. I'm going to click on this line or this arc, and then I'm going to click on this diameter. And I'm going to force a tangent relationship. So you can see that it's fully defined from this and this based off of the reference geometry that we already established. Now again, if you didn't have this through hole to take advantage of, you would have to draw the the diameter of it. And I'll just show you really quick. If you're doing this on your own, that value there is 2 inches, not 2.25 like I said before, but that's a 2-inch reference, and you would just have to draw these arcs accordingly. And then again, I could take my smart dimension and I can create reference pieces of geometry. These are not driving it, they're just reference. So if I changed any of these pieces of geometry here, you would see that the values would actually update. So they're just referenced. I'm just showing it to match up against the values that we saw in the blueprint. Okay? All right. So as I said, this little portion here, I can actually mirror it over this 60-degree line that we drew, or this angle. So just like what we did in the last video when we mirrored over the sketch across the horizontal line, let's go ahead and select the Mirror Entities inside of the Sketch tab. And inside Mirror Entities, we'll select the entities that we want to mirror, which are going to be this line and that line, or those two arcs. And we're going to mirror it across that 60-degree angle that we just created. So we'll click on that, and then we'll hit the green check mark. So you have to think about this. So we took 60 degrees, and then we mirrored it, so we doubled it. Now that that's full 120-degree wedge that we saw this patterned out to be. Okay? Now we can go ahead and utilize the the circular sketch pattern, which is the next step of like the next hierarchy of mirroring entities. So if you come here to sketch, and then underneath linear sketch pattern, which is underneath mirror entities, you hit the drop down menu and you locate circular sketch pattern. So you click on circular sketch pattern, and the parameters, this parameters box, this is the center of where you want to rotate around. So the parameters, I'm actually going to select the center of my part, or the origin. So you can see that it's represented by that 0.2. And then now I have the, there's like a number or pound symbol inside of a circle with a couple other circles. So I have to change that. That's the number of instances. So right now it's defaulting to 4. I want to update it to 3. So I'm going to highlight that and change it to 3. Now we have to choose what entities we want to pattern. So down here in the entities to pattern, we're going to select this arc, and this arc. So we have 3 arcs included around this point, and we're going to rotate it 3 times, or pattern it 3 times. And then we'll hit the green check mark. Okay, so you can see how easy it was for me to draw the profile or the outline of this fidget spinner by using the mirror command as well as the circular pattern command. I didn't have to draw every single line individually. And if I have to make any changes, all of these are now linked to each other and they'll update accordingly. So let's go ahead and move into the extruded cut command now. So we finished everything that we need in this particular sketch. So we'll go to features, and then we'll go to extruded cut. So inside of this extruded cut, let's go ahead and choose from a couple different profiles. Let's go ahead and select the outside profile. So if we see this highlight red, that's going to include everything outside of the fidget spinner profile. So I'll click on that the outside profile there, and I'm going to change it from blind to through all, and then I'll hit the green check mark. So got rid of all that geometry. I'm left with the fidget spinner profile. So we're moving pretty good. We have the profile. Now we just have to consider some of the details. So I want to go ahead and pattern this specific hole right there into these other spokes of the fidget spinner. And the way that we can do that is we can either just draw the circles off of the center points of these circles, but I'm going to try to utilize that circular pattern command that we just used again. So let's start a sketch on this face. And when I click on that face and it's highlighted, I'll click on sketch. And inside sketch, I'm actually going to click on that circle, so that through hole, which is going to be the locating pin. I'm going to, while it's highlighted, I'm going to click on convert entities. So when I clicked on convert entities, it's actually going to pick up that circle, and now I can use that as geometry to pattern. So just like what we did before, I'm going to use the circular pattern inside of the linear pattern. So if you go to sketch, linear pattern, hit the drop down, circular pattern. The parameters, we have to choose a center point, so it's going to be the origin. The number of instances, we're going to make it 3. And then the entities to pattern, we're going to select that hole. And then we'll hit the green check mark. And I'm actually glad that it did this, because sometimes SolidWorks does not recognize the true origin, or if it does recognize the true origin, it doesn't lock it down to it, especially here inside of the sketch command. So sometimes you can actually get values or patterns that are underdefined or blue. So if I pull these off of the origin, you can see that it's actually moving. However, if you just click on the origin and then hold it down when you click and then drag off and then drag back on, it'll relink itself back to the origin. So that's just a little quick tip. Sometimes it comes up, sometimes it doesn't. And we'll hit the green check mark. And we can go ahead and do a extruded cut through these holes now too. So we'll go to Feature, Extruded Cut, and then we'll go ahead and do through all and then hit the green check mark. Okay, so we're going to continue on with these other details. So if we hop back over here to the blueprint, I have some of these reveals here that are going to include a fillet as well as a ball mill or an edge break that's going to be on the top edge of that ball mill. So it's almost like a two-tiered, and you can see that here. We have the top view, we have the cross section, and then if we zoom in here, this is the detail view of that cross section. So we have some radii that we have to consider, and then at the depths of where they're going to place. So let's go ahead and start working with some of those. I'm going to go start with this top one here, and I'm going to start a sketch on this top base. So I'll click on that base, and then I'll hit the green check mark. And then there, I'm going to go ahead and draw a circle. So this is going to be a little bit of a tricky dimension for us because it's not a full radius. And if we look at these edges here, you see how it's not a fully tangent radius? Now that's not a bad thing, it's just a design choice. And we have to realize or understand how to process it. So to process this one, we're just going to go down to this 0.93 depth, and then we're going to try to place this 0.1875 radius. However, I have to try to play around with the value of the total OD, or the diameter of that reveal, and I have two reference points here. So this 0.5 is going to be the internal reference point. Now, I might have to make it a little bit bigger to get down to that size because we're kind of truncating, or we're shorting this full radius. So I'm going to come back here. I'm going to go to that sketch. I started it. And I'm going to start another sketch, or sorry, another circle. And I'm going to reference this hole, or that through hole that we're using for the locating pin again. So I can wake it up by hovering over the edge, and then I can see the center point of it. Click on it, and I'm going to drag a circle out. Okay, and then I'm going to hit the escape key, and I'm going to smart dimension this. So I'm going to go to smart dimension, and I'm going to change this value here. Instead of to 0.5, I'm going to make it 0.59375. So I'm going to make it a little bit bigger. And I'm going to hit the green check mark. And then I'm going to go to Features, Extruded Cut, and then the value that we saw before was a value of 0.09375. So I'm going to change it not from through all. We're actually going to go to blind this time, and I'm going to make it 0.09375. So I'm going to have this little shelf here. Now, this is where I was saying it gets a little bit tricky. And if I go and I access the fillet command because I want to put a fillet here on that corner to break the edge, I'm going to go to fillet, and I'm going to type in a value of 0.1875, which is the radius that we were seeing here. And it's going to be in that corner. So it's that first step. And I'm going to click on that corner there. And you can see that I have a little bit of flat here, and that's like the full radius. But if I hit the green check mark, and then I get this measurement here, I'm at that full 0.59375 dimension. So I want to be a little bit smaller than that. So I'm going to click on this feature again, or this fillet. And the reason why I'm showing you this is because I want to show you how much power you have in controlling some fillet geometry. So if I scroll down here in the fillet tab, you actually have the ability to see fillet options. And if you open up that fillet options, you can have the overflow as the default, which is shorting the radius this way right now. But if I want the full radius to be applied the other way and take up this whole detail to basically start from this edge as opposed to this edge, I'm going to actually choose to keep surface. So that keep surface command is going to allow us to start from the center of that rather than the edge of that. And it's going to shrink down our geometry just a little bit. So you can see that this projection here is going to fill in. And I'll hit the green check mark, and we'll see that in real time. So it's actually going to fill that in. So that's going to be closer to that 1/2 inch reference dimension that we were pulling. So Again, you could probably just draw the circle as is, two sides, and then fill it in that way, but I just wanted to show you how you can control a fill command using that overflow. All right, and we're going to go ahead and pattern this around and then mirror it to the other side. So much like what we were doing in the sketch command when we were doing sketch patterns for circular, we're going to use the features, and inside feature we're going to use the circular pattern here in that feature tab. So inside of the feature tab, we're going to go to linear pattern, hit down the drop down menu. We're going to grab the circular pattern, and inside circular pattern, much like how we had a point or a reference that we were going to choose as the origin, the direction, we're just going to choose a circular entity. So I'm just going to grab one of these circular faces, and then I'm going to choose the features or the faces that I want to include with this pattern. So I might not be able to access that first or that initial extrude cut. So what I'm going to do is I'm actually going to expand out my feature tree here. So whenever you're in a feature where you're doing something with the properties here, you can always access your feature tree by just finding the name of your part, hitting the expand, and you can see all of your features here. So if I was going to try to just feature, for example, that fillet, and I tried to change my number of instances to 3, it wouldn't apply because there wasn't an extruded cut included with it to build those fillets underneath it. So what we'll have to do is, instead of just selecting the fillet, I'm going to actually clear that or delete that. I'm going to choose the cut extrude 3, which is going to be the last cut extrude that we did, and also the fillet. So I'll grab the fillet as well. So now I've populated the features that I want to pattern with 2. So it's the cut extrude 3 as well as the fillet 1. And then again, update your number of instances to 3, and you should be able to hit the green check mark. So whenever you see something like this where rebuild, there's a good check before you just like abandon it. Sometimes it will default here to geometry pattern. If you turn off geometry pattern, and sometimes you have to turn on geometry pattern, sometimes you just have to toggle between the two and then hit the green check mark, and that applied our geometry. So just a wonky workaround that we have to keep in the back of our mind whenever we're doing circular patterns like that. So again, if you did your circular pattern and it didn't apply when you selected these two entities, just go down here to options and then toggle between geometry pattern, either on or off. Sometimes you just have to check it that way. And then we'll hit the green check mark, okay? And then we're going to go ahead and we're going to take these entities and we're going to mirror it across the center of the part. So we talked about this in the last video, but the heart of the part is basically in the center of the centerboard. And the reason why I designed it that way is because I can now utilize the top plane to mirror across. So I can take some of these features like these fillets and I can actually mirror it across that top plane. So just like how we did with the mirror function in Sketch and the circular pattern in Sketch, we could use the circular pattern in features as well as the mirror pattern in features. So here inside the features tab, let's go ahead and grab the mirror tool. And then the mirror face, this is where we might actually have to utilize this feature tree, the expanded feature tree, to get our planes. So I have to expand this out, and then my mirror face is going to be that top plane. And then if I have that top plane selected, let's go ahead and choose the features that we want to mirror. So we can mirror the cut extrude 3, the fillet 3. So that's going to mirror those two details as well as the circular pattern that we just did. And then let's go ahead and see if that will apply. So green check mark and take a look at that. So I'm saving myself quite a bit of steps here by just mirroring and patterning rather than, drawing a detail, extruding it down, and then filling it in with a fillet and doing that for each one of these and then doing the same thing on the backside. So I'm saving a lot of space on my feature tree. I'm saving myself a lot of clicks and a lot of chances for user error. So we have these two details now. Let's go ahead and apply the edge break of the outside diameter or the outside profile edge. So I'm going to go over here to fillet, and underneath fillet, I'm going to change this because I want to utilize this for a 5-axis swarf application. And instead of it just being a typical 45-degree angle, which we have a 45-degree chamfer, I want to change this to, let's say, like 30 degrees or 60 degrees or whatever degree amount that you want, because I can actually rotate and swivel the table in such a way that I'll simultaneously trace out the profile at whatever degree angle that you want. So I'm going to now change this to a chamfer. So fillet, chamfer, and I'm going to grab this top edge here, and I'm going to make sure that the angle is facing down. So I might have to actually flip the direction. And then I'm going to change this from 0.393, which is the default dimension, to, I'm going to take a look here at my drawing, to 0.09375. So I'm going to change that to 0.09375. And then I'm going to update the angle to 30 degrees. So I want it to be cutting a little bit more acute than it was here, where it was equilateral at 45 degrees. So I could have cut that 45 degrees with the chamfer tool. However, when I go to that 30 degrees, I would either have to get a specific chamfer tool at 30 degree set, or I would do the swarf pattern, which is what I'm going to do here in Mastercam in the next couple videos. So I'm going to grab that edge as well as this edge here. So this is kind of funny. You can see that this edge is projecting the way I want. However, this edge is projecting obtuse, which is truly 60 degrees. And the way that we can control that is, as long as we have that edge 2 selected, we can go ahead and choose flip direction on that, and it'll flip it back into its correct location there. So make sure you see like a symmetrical pattern here, and then hit the green check mark. All right, so now we have a 30 degree edge break that we'll eventually have to do a 5-axis continuous or simultaneous swarf on. And we have our details here with the reveals. So the last thing that I want to talk about here is actually the edge breaks on each one of these reveals. Now, I'm not saying that they're typically going to be like super sharp and that we have to break them, or that we should add an edge break, but more from like a stylistic or a design point of view, I want to show you 2 ways of how you could approach this. So you could, if you wanted to, take your fill command and then fill that out, but you'd have to do a lot of surfacing. Likewise, you could take your chamfer tool, but it might be hard to control this chamfer angle, especially if it's being built off of a radius. So you can see it's kind of getting out of control there. So the thing that I want to do is actually to break this with another ball mill. So it's going to be like 2 steps or 2 sets of ball mills. And the easy way to do it, which may or may not be the preference here, is to actually use a sweep cut. And sweep cuts are very powerful. If you've ever used a sweep tool before, you can create pipes pretty much instantaneously. But with the sweep cut, I can actually project the radius of my ball mill and break edges pretty easily as well. So inside of the Features tab, I'm going to locate the sweep cut command. So if we click on sweep cut, we're going to be prompted with this new sweep cut sweep properties bar. There's detail here. So what I'm going to choose is I can either set up my own projection that I want to cut through, or I'm just going to use a standard circular profile. So if I click on circular profile, it's going to remove that option to apply that my predetermined profile or that user defined profile. And now I just have to select a path. So if I click on this path, I can click on this edge there, and you can see that it's almost like reverse fillet. And if I look at my details here, I have a 0.0625. So I'm going to type in 0.0625, and I'll hit the green check mark. And I could break my edges just like that. This is fine. I have no problem with this. However, I like to have a little bit more control. And if you want, you can pretty much continue on with this video and finish off your fidget spinner by patterning this and then mirroring it once again. However, I want to show you how we can utilize the user-defined profile and maybe control our geometry just a little bit better. So again, this is pretty good. You can use this in most instances. Just do that cut sweep like that and then control it. If you wanted to update it, you can right-click and edit the feature. And then you can go ahead and change, the values as you need. All right. So if I want to take this one step further, I'm going to go ahead and click on that cut sweep one, and I'm going to go ahead and delete it and get rid of it. So now we're going to do a user-defined profile and project it against a path to better control the offset of a tool or a ball mill while utilizing the swept cut command. Now, this is going to take a little bit longer for us to set up. However, I think that this is the best case use scenario for industry because we can actually offset that tool so it's not fully engaged at the tip or the quadrant or the entire edge. So let's go ahead and start a sketch here on the top face of our profile, and then I'm going to right click and start a sketch. Now what we're going to do is we're going to convert the entities of this edge here of the reveal, and I'm just going to select it, and I'm going to come up here into sketch and just select convert entities. Now what we're going to have to do is we have to set this up in two separate sketches because while utilizing the swept cut or any sweep command, you have to have a path and a profile. And you have to access those two sketches separately, so you can't just like drive right in from the features command. So what we'll need to do is actually exit out of the sketch. And I'm going to do this on my end so it's a little bit easier for you to see. So I'm going to right click on the sketch and I'm going to go to sketch color and I'm going to change it to red so that way you can at least see it. It's not gray on gray. Now, what we're going to do now is we're actually going to create an additional sketch on the right plane for the tool to be projected or our user-defined profile. So let's go ahead and start a sketch here on the right plane. I'm going to right click it and start a sketch. And I'm just going to rotate and kind of zoom into this area right here. Now, what we're trying to do is we're going to create a vertical line in Y, and then we're going to create a horizontal line going left in X. And then we're going to place the tool at the center of that endpoint. And that's going to be like the offset of the tool and how we can control it, and we can smart dimension it in X and Y. Now, what we're going to do is we're going to go to our line tool and actually create a center line. And while using the centerline tool, I'm not going to try to fish for this edge and try to make it coincident, because when we're on this right plane, where is coincident truly? It could be coincident here, 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 anywhere on this arc here. So we're actually going to try to force the relationship by using the pierce command. And the way that we can do that is I'm just going to draw a line out here to the right, and I'm going to go and make sure that it's going up in Y, and I'm going to get a vertical relationship. Okay, and then I'm going to go left in X, and I'm going to get that horizontal relationship. And then I'm going to go ahead and escape out of that because I don't want to draw those lines anymore. Now, like I was saying, I want to make sure that this point is intersecting the exact quadrant of the right plane on this path. So let's go ahead and hold down the control key, grab that point, grab that edge, and then let's grab the pierce command over here on the left-hand side under relations. So that's actually making the point intersect the right plane as well as that profile. So very powerful way to control the intersection of that quadrant. All right, so I'm actually going to draw the tool here at the endpoint, and I'm going to show you what it looks like as we move this around in X and Y, but that value is actually going to be a 0.0625 radius, and we're drawing the full diameter of the tool right now, so that's going to be double, which is going to be 0.125 or 1/8 of an inch. So using the smart dimension, I'm going to smart dimension this diameter to 0.125. And then you can kind of imagine as I start to move this along the edge here, what's actually going to be taken out, as opposed to in the previous example where it was just at the center, which is going to be full engagement and actually undercutting there on the bottom left. So I'm going to actually move this a little bit over here, and you can see what that little section or that sliver is going to be removed with that swept cut command. So using the smart dimension tool, I'm going to dimension this at 0.03125 in Y, and then I'm going to do the same thing in X, 0.03125. So we've actually offset the tool that 30 thousandths in X and Y off of the profile of that edge. So I'm going to hit the green check mark, and once again, I can't drive right into the swept cut command, so I'm going to exit sketch, and once I'm out of both of these sketches, I can go into the features, and inside of features, I'm going to use that swept cut command now. So under swept cut, we have the option to choose between a profile and a path. And the profile is always going to be that blue box, and the path is always going to be that pink box. Now, the profile for us is going to be that tool that we just drew, so that diameter. And then the path is going to be that contoured edge that we drew on the top face. So I'm going to select that sketch right there. So we should see sketch 7 and sketch 6 respectively in those two boxes. And I'll hit the green check mark. And that looks pretty good. I'm not seeing any breaks or bends, and it looks like the swept completed with no issues. So one thing I want to check, and I talked about this earlier before I go ahead and move on to the mirroring and the patterning, is the reference dimensions that we saw here on the two edges. So I saw a reference dimension of 0.59 for the outer edge and then a 0.5 for the inner edge. So if I come back into the model here and I go to evaluate, I'm going to use that measure tool. And using that measure tool, let's go ahead and grab this diameter right there. And we see a value of 0.499, which is going to round up to 0.5. And I'm going to grab that edge right there, which is going to be 0.589, which is going to round up to 0.59. So I think we did a pretty good job at matching those reference dimensions while going through the cut and then filling in it with a fillet, as well as using this offset and the swept cut. So I'm going to go ahead and say we're safe to move forward and mirror this and then pattern it around. So let's go ahead and hop over here to the Features tab and then use the mirror function. So underneath mirror, we're going to choose a plane to mirror across. So we're going to have to expand out our feature tree here and locate that top plane. And then we're going to use the feature to mirror, which is going to be the swept cut that we just did, or we can choose it from the last feature in the feature tree. So I'm just going to grab it from the model itself and then mirror it across and then hit the green check mark. So you can see here that I didn't get any issues, which I'm thankful for with that mirror. So if you're not getting yours to complete, go ahead and try toggling between this geometry pattern and see if it'll actually rebuild that way. And then last, we'll go ahead and pattern this around using the circular pattern function. So underneath features, we're going to go to linear pattern, and then we're going to go to circular pattern. And then the direction, we're just going to choose one of these circular edges. And then the features are going to be the last two features in the feature tree, which is going to be that swept cut and then the mirror. So I'm just going to grab these last two features from the feature tree and then go ahead and hit the green check mark. So you can see there, we did a pretty good job mirroring it over and patterning it around on all of these different spokes, which saved us a lot of time, especially if we had to go one by one and try to project that tool and offset it on each one of these. So you can see that there's a lot of power in the mirroring and the circular patterning commands in both the sketch environment as well as the feature environment. So if you can try to harness and utilize those, you can actually cut down a lot of information here in your feature tree. And likewise, we explored some more edge breaks and how to use and control the fillet tool as well as the swept cut command and using it to offset the tip of the tool. So I'm going to consider that done. I'm feeling pretty good about that. And I'm going to go ahead and save it and call this one a wrap. So let's go ahead and file, save as, and we'll just title this 3-spoke spinner. And thanks for watching, and I'll go ahead and catch you in the next one.